Hello and welcome to a look at the binomial distribution probability with me, Andy Duncan, here at Finlingo.com. Binomial distribution probabilities are useful in finance when trying to work out expected success rates. We'll explain the theory and then derive the general equation before we get to an actual finance question. This is Sean. He's a stock picking guru who uses an unusual strategy to pick successful stocks. What he does is to blindfold himself, then reach into a magic bag which always has two choices. A successful stock is a green one, an unsuccessful stock is a red one. In this particular magic bag there are 4 balls. 1 is green and 3 are red. And here's where the magic comes in. Because every time Sean pulls out a successful green ball from the bag, a wormhole connection is made to an alternative infinite universe which is absolutely full of green balls. One of these is sucked through a wormhole into the bag to replace the one Sean just took. The same trick works for the red balls. Every time Sean pulls out one of these, a different wormhole connects to a second universe, this time one full of red balls. One of these is always sucked out to replace the one Sean just took. So whatever happens, the magic bag always has 1 green ball and 3 red balls. This means that Sean's chance of pulling out a green ball from the bag is always 1/4, and the chance of him pulling out a red ball is always 3/4. For use in the binomial distribution equation later, we can use some special notation for this. P, or the chance of success, is equal to 0.25, and the chance of failure, the complement of P, is 1 minus P, which is equal to 0.75. So far, so good. Sean decides he'd like to draw 5 balls out of the bag at random. We'll call this 5 trials. He'd like to know his chance of pulling out exactly 3 green balls. So let's do the mathematics. To get green, 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 and then red and red, the chance of that happening is 0.25 times 0.25 times 0.25 times 0.75 times 0.75. Or, to use the notation, that's P times P times P times 1 minus P times 1 minus P, which is also equal, of course, to 0.00879. Or, to be even more concise, that's P cubed multiplied by 1 minus P squared. Brilliant, thinks Sean. I've now worked out the chance of getting 3 green balls whenever I pull 5 balls out of the magic bag. And it's equal to 0.879%. But then he realises that this is a bit low. He knows the chance of getting a green ball is only 1 in 4, but surely 0.879 for 3 out of 5 is a bit low. And then he realises his mistake, because the order of the balls doesn't matter. It doesn't just have to be green, green, green and then red and red. It could be in any order. So Sean gets into a cunning time machine and visits a number of different universes. In the first universe he pulls out green, 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 red and red. In the second universe he pulls out green, green, red, green, red. In the third universe, green, green, red, red, green. In the fourth, green, then red, then green and red. In the fifth, green, red, green. The sixth, green, red, red, green and green. And in the 7th, red, green, green, green and red. In the 8th, red, green, green, red, green. And in the 9th, red, green, green. And in the 10th, red, red, green, green and green. He does visit a few other universes, but discovers that there is no other possible combination of 3 greens and 2 reds. So let's take a look at a couple more mathematical gizmos. The number of trials is 5, so n equals 5. The number of green balls he needs is 3, so that's k is equal to 3. Is there a formula out there, thinks Sean, that uses 5 and 3 that would give me an answer of 10? And suddenly he realises that this would be the combination formula, which is n factorial divided by n minus k factorial multiplied by k factorial. If at this point you're unsure about combinations, you might want to watch our video on this which derives the formula. Back here in this video, using n equals 5 and k equals 3, we can expand the general formula for combinations for 5c3 into 5 factorial divided by 2 factorial multiplied by 3 factorial. And this is equal to, drumroll please, 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 3 times 2 times 1. which after a bit of fun and jiggery pokery is equal to 5 times 2. This itself is equal to 10. And this is exactly the number Sean was looking for. This is the exact number of universes where a different selection pattern is possible. So getting back to his problem, Sean changes p cubed multiplied by 1 minus p squared to 5c3 multiplied by p cubed multiplied by 1 minus p squared. And this is equal to 10 times 0.00879, which is equal to 0.0879, and this is 8.79%. And Sean thinks this number looks a lot better than 0.879%, which he got earlier. Now we've got the theory worked out, let's try a real financial exam question on Finlingo.com. To answer the question, we need just three elements. We need P, N, and K. We can see that P equals 0.353, so 1 minus P must be equal to 0.647, just like the question says. This roughly equates to a magic bag with 1 green ball and 2 red balls. We'll just have to fudge the exact numbers a tiny little bit. Moving on, N is equal to 5 and K is equal to 3. The question wants to know how many times Liam can expect 3 successful outcomes from 5 different stock selections, or P of x equals 3 equals 5 factorial divided by 5 minus 3 factorial multiplied by 3 factorial, all multiplied by P cubed multiplied by 1 minus P squared, which is equal to 5 factorial divided by 2 factorial times 3 factorial multiplied by 0.353 raised to the power 3 and 0.647 raised to the power 2. And that's equal to 10 times 0.004399 multiplied by 0.41861, which is equal to 0.18413, or 18.41%. Let's get back to Finlingo and check if this works out. Find the right answer, select it, then move on. Head over now to Finlingo.com to access the Finlingo question tool, where you can answer an infinite number of questions on the binomial probability distribution, along with hundreds of other question types to pass difficult financial analysis exams. That includes the CFA. Finlingo. Speak finance fluently.